Hello, Sawyer here. Welcome to Real Numbers, the weekly show that presents real-world math problems for you to solve. The last few episodes, we've been working on probability questions, but this week, we will shift gears and instead think about a geometry puzzle. Let's ready our protractors. For this episode's problem of the week, we are designing the shape of a snow cone holder. The specs for the snow cone holder: it will be shaped like a cone. The lip of the cone has to fit around the equator of a 5 centimeter radius sphere of flavored slush. And the volume of the cone has to equal the volume of the lower half of that 5 centimeter radius sphere to be fit into it. Given these requirements, what is the exact shape the snow cone holder should take? Submit the description of the cone on this page, along with your work of how you got it. Now let's solve last week's problem, whose episode has a link in the description of this video. Your generous grandmother had collected 3 $20 bills and an unknown number of $1 bills in a piggy bank for you on Saturday. On Sunday, she put in one more bill, which was 50-50 to be a 20 or a 1. Then on Monday, you picked out a random bill from the piggy bank and got a $20 bill. What is the probability that your grandma added a 20 on Sunday? I really like this problem because at first it seems like there's not enough information to solve it. You don't even know how many total bills there are in the piggy bank. Somewhat surprisingly, this doesn't end up mattering for the probability that we are calculating. Let's define the constant n to be the number of $1 bills in the piggy bank on Saturday. There are 2 random events we are considering: the type of bill that Grandma added to the piggy bank on Sunday, and the type of bill that you pick out from the piggy bank on Monday. Let's call added 20 the event that Grandma added a $20 bill to the piggy bank on Sunday, and added 1 the event that she added a $1 bill. We know the probability of added 20 is the probability of added 1 is 1/2. We will call picked 20 the event of you picking a $20 bill on Monday. And so what we want to compute is the conditional probability of added 20 given picked 20. By Bayes' theorem, the probability of added 20 given picked 20 equals the probability of picked 20 given added 20 times the probability of added 20 over the probability of picked 20. The probability of picked 20 given added 20 is the probability that we drew a random bill out of the piggy bank after Grandma had added a 20 and it was a 20. So there are 4 $20 bills and n $1 bills in the bank, so the chance that a random bill picked out is a 20 is 4 over n plus 4. We know that unconditionally, the probability of added 20 is 1/2. Now to compute the unconditional probability picked 20, we need to break it up into cases based on what bill Grandma added. The probability of picked 20 equals the probability of added 20 times the probability of picked 20 given added 20, plus the probability of added 1 times the probability of picked 20 given added 1. That's 1/2 times 4 over n plus 4, plus 1/2 times 3 over n plus 4, which is 7 over 2n plus 8. So we can plug all these into Bayes' theorem to get the probability of added 20 given picked 20 is 4/7. As we see, the n's cancel out and the final conditional probability does not depend on the number of $1 bills in the piggy bank. The answer we got for probability of added 20 given picked 20, 4/7, is slightly greater than 1/2, which was the unconditional probability of added 20. That is, we updated our prior probability of 1/2 by increasing it, because the event picked 20, which is sampling a random bill and getting a 20, is evidence that there are more $20 bills in the piggy bank. A second way to compute this conditional probability is to consider 2 copies of the piggy bank, each with 3 20s and n 1s. Then one receives a $20 bill from Grandma on Sunday, and one receives a $1 bill. Drawing a random bill from one of these 2 piggy banks is like determining the results of both random events at the same time. If the bill comes from the left piggy bank, Grandma added a 20 to the bank. If the bill comes from the right, she added a 1. Since the prior probability of being on the left or right is 50-50, and there are equal numbers of bills on both sides, we know that all of the bills are equally likely to be drawn. Now, conditioning on drawing a $20 bill means we restrict to just the 7 possible 20s to draw from the 2 copies of the piggy bank. 4 of those 7 20s come from the left piggy bank, so of the set of all possible worlds where we picked a 20, 4/7 of them occur when Grandma added a $20 bill to the piggy bank. Therefore, the probability of added 20 given picked 20 equals 4/7. Okay, let's shift our mathematical gears from probability to geometry and get to designing a snow cone holder. What shape of cone has a lip that will fit around a 5 centimeter radius sphere's equator and also a volume equal to half the volume of that sphere? Submit your answers, comments, and thoughts, and I'll see you next week.